Okay. So let's say, for example, we wanted to multiply. Oops. Three plus 5i by its complex conjugate. Okay, so we know that its complex conjugate is 3 minus 5i. So that gives us 3 plus 5i, 3 minus 5i. So if we do the FOIL method, we have 3 times 3, which is 9. We have 3 times negative 5, which is negative 15i. We have 3 times positive 5, which is plus 15i. And we have positive 5i and negative 5i, which is negative 5i squared. Okay, so we have our 9. Those two disappear. So we have minus 5 squared and I squared, so that would be 25i squared. You got to remember, I squared equals negative 1. That's minus 9 minus 25 times negative 1, which is 9 plus 25, which is 34. Okay. We don't have to put it in A plus BI form since we already knew that multiplying two conjugates will give us a real number. Okay. Now, if you wanted to just use the previous formula, three plus 5i, 3 minus 5i, we know that A is equal to 3. Bring that up a little bit. And we can see that our B is equal to 5. Because remember, it's just in the form A plus BI, A minus BI. And from the previous page, we know that's equal to A squared plus B squared. So if you wanted to, just using that, we could have just made it 3 squared plus 5 squared, which is 9 plus 25, which is 34. Okay. Like I said, it's a shortcut, but it's one of those where you can easily work it out and get the same problem. So that's why I'm saying you don't have to remember it, because actually working it out doesn't take like a really long time. Yes?
So in this case, is A and B always going to be positive? Because like if you flip it around, you would still get a positive for B, right?
Yep, you'd still get your B squared, because your I squared will always make that a positive. So like I said, with normal difference of squares, it would just center out and you still have the minus, but that I squared kind of changes everything.
Right.
Okay, any other questions on this one? All right. Okay. Now the reason we started off with this multiplication when we're supposed to be talking about division is because when you divide, you have to multiply everything by the complex conjugate of the denominator. Okay, so let me write that out and then we'll give a few examples. Okay, so to divide complex numbers, you want to multiply the numerator and the denominator by the complex conjugate of the denominator. That's why we started off the division section talking about more multiplication. All right, so let's say, for example, you want to divide, say, 3 over 6 plus I. Okay, so we know that, let me just rewrite that. We have 3 over 6 plus I. The complex conjugate of 6 plus I is 6 minus I. Okay, so that means we're going to multiply the numerator and denominator by that complex conjugate. So it's going to be times 6 minus I over 6 minus I. Okay, so if we just put those together, 3 times 6 minus I over 6 plus I, 6 minus I. You can either use the formula for the denominator or you can just FOIL it out. So if you decide to FOIL it out, and this one you just distribute, you end up with 3 times 6 is 18. 3 times negative I is negative 3I. Over, if we FOIL it out, we have 36 minus 6I plus 6I minus I squared. And we remember that I squared equals negative 1. So these two will always cancel out. So you have 18 minus 3I over 36 minus negative 1. Okay, which will give us 18 minus 3I over 37. Now with that one, they'll probably want it in A plus BI form. So you just separate it like you would any variable. Well, like you would a variable since it's not a variable. So you have 18 over 37 minus 3 over 37I. Okay, and that would be your final answer. All right, any questions on that one? Yes.
We can still put I in the numerator there, right?
Yeah, you can, but with that one, they probably just want it on the side because it would be the B is actually your 3 over 37. So they probably just want it in that form. I don't know with these if they still accept it in the numerator or not.
Okay.
All right, leave that up for a few more seconds. Oops. Okay. So let's say if we wanted to divide 1 plus 2i over 3 minus 4i. Okay, so just like before, we find the complex conjugate of the denominator. Okay. We know the complex conjugate of 3 minus 4i is 3 plus 4i. So that means we have 1 plus 2i over 3 minus 4i times 3 plus 4i over 3 plus 4i. Okay, so if we just go ahead and bring those together, we have 1 plus 2i times 3 plus 4i over 3 minus 4i, 3 plus 4i. Okay, so all we have to do is FOIL both of them if you want, or you can use the formula for the bottom. Okay, so we end up with 1 times 3 is 3. Our outer is 1 times 4i, which is 4i. Our inner is 2i times 3, which is 6i. And our last is 2i times 4i plus 8i squared. Over, you have 9. Your outer is 12i. Your inner is 12i. And your last is negative 16i squared. Where, of course, we know that I squared is negative 1. So we go ahead and combine those two. So we have 3 plus 10i plus 8 times negative 1. And, actually, one of these should have been a minus. Yep, sorry about that. That one should have been a minus 12i. So those two cancel each other out. So you have 9 minus 16 times negative 1 is negative 16. Nope, actually I could have just wrote it like I did that one since I have to rewrite it anyway. So I'll just write that as 16 times negative 1. Okay, so now we have that here. So we have 3 plus negative 8, so that gives us negative 5. Plus 10i over 9 plus 16 is 25. So if we separate that, we have negative 5 over 25 plus 10 over 25i. Well, we can go ahead and simplify those. Okay, so 5 goes into 5 once. 5 goes into 25 5 times. 5 goes into 10 twice. 5 goes into 25 5 times. And we put our I. Okay, so all the other rules pretty much stay the same. Just that I squared switches things up a little. All right, any questions on that one? Oh, that was this here. That just becomes 3 minus 8. Because that negative 1 times 8.
Okay. I did it differently. I didn't get that.
So 3 minus 8 equals negative 5. Zoom in. 4. All right. All right, so let's say, for example, if we wanted to divide 4 plus square root of negative 16 over 2 plus square root of negative 4. And you want the answer in a plus bi form. Okay. So first thing we want to do, we want to put it in real and imaginary terms. So we can just write that as 4 plus I square root of 16 over 2 plus I square root of 4. Okay, so this becomes 4, square root of 16 is 4, so 4 plus 4I over 2 plus, this becomes 2, square root of 4 is 2, so 2I. Now your first instinct would be to multiply it by the complex conjugate of the denominator, but if you look closely, you know you can factor a 4 out of those two. Nope, so you have 2 plus 2I over, and you can factor 2 out of both of those. Nope, actually you can leave that same. Don't know why I did that. So you just have 2 plus 2I. Or you can leave it as 1 if you want to. Duh. Why am I putting a 4 up here when you factor out a 2? There we go. Okay. So now your 2 plus 2i's can just cancel each other out. So you're just left with 2, or 2 plus 0i. Now if you did it the other way, it would still work out to that, just a lot more work. Okay, so you could have multiplied it by 2 minus 2i over 2 minus 2i and still would have all worked out. Okay, any questions on that one? Okay, so what if we wanted to divide 7 over 2i, and we want it in a plus bi form? Okay. So with this one, if you remember, 2i is just 0 plus 2i, which means 0 minus 2i is the complex conjugate. Uh-oh. 0 minus 2i, which is just negative 2i. So that means if you're looking for complex conjugate, that's just changing the sign of the complex number. I mean, not complex, the imaginary number. So that means 2i and negative 2i are complex conjugates. Okay, so you don't have to always write it out as 0 minus 2i and 0 plus 2i. If you see a single term complex or imaginary number, just change the sign in front of it and you're all set. Okay, so that means if we have 7 over 2i, we just multiply it by negative 2i over negative 2i. Okay, so that means we will end up with 7 times negative 2 is negative 14i over 2 times negative 2 is negative 4, so you have negative 4i squared. Again, that I squared is going to give you negative 1. So I squared equals negative 1. So we end up with negative 14i over negative 4 times negative 1. Negative divided by, well, actually that becomes negative 14i over positive 4, which becomes negative 7i over 2, which becomes 0 minus 7 over 2i. That's your a plus bi form. Yes?
In the beginning, since there's no like a in the denominator, could we have just multiplied the numerator and denominator by I?
Yep, actually that one would have worked since it's just one term.
Mm-hmm.
Yep, that one would have worked also. All right. Okay, then we'll do one more and we'll move to the powers of I. Anyone still writing? Okay. So if we wanted to divide, bring that down some. Negative 1 plus 9i over negative I. Okay, so we know that negative I and I are complex conjugates. That means we have negative 1 plus 9i over negative I. We just multiply it by I over I. Okay. You could have did the same thing on the previous one because this is just like saying negative 1 times I. If you multiply it just by I over I, you could have did the same thing with 2 times I and it would have still worked out. Okay, so just put it all together just because you don't have to do this part. Times I over negative I times I. So we go ahead and distribute. That's negative 1 times I. So you have negative I. You have 9i times I. That's plus 9i squared. Over negative 1 times I is negative I squared. Okay, so that's going to equal negative I. You have to remember that I squared is negative 1. So that's plus 9 times negative 1. over negative -1. Okay, so that gives us negative I minus 9 over 1, which is negative I minus 9. But if we want it in the complex form, it's negative 9 minus I. So it's just kind of switching it up. All right, any questions on that one? All right. Leave that up for a few more seconds. Oops. Okay. Now we're going to look at operations involving powers of I. Might as well restart.